All right, we're going to find the we can use another test here. It's slightly different from the ratio test. It's called the root test, the nth root test sometimes, or just the root test. And it's very similar to the other one, except we're only looking at the nth root of the absolute value of a sub n given a series with a sub n as a general term. So we're working with this series here. So if this root, the nth root, said the limit of the nth root as n goes to infinity is one of these, r less than 1, we have convergence, greater than 1, divergence, equal to 1, test fails, we've got to try something else. This is a useful test for problems like this one, where you have n, your variable, your index variable, in the exponent of your expression. Because what this effectively does, this test removes it from the exponent. Now, of course, if you were to find the limit as this term as n goes to infinity, you would obviously have 0. But that in itself doesn't tell you anything. Now, you should suspect that this converges. I mean, that denominator rapidly heads to 0. I mean, 1 over n to the second power would converge. So 1 over n to the n, for surely it'll converge. Anyway, here's how we can show it though. Set up r, it's the limit as n goes to infinity of this 1 over n to the n. And we don't really need the bars for this problem because it's all positive anyway. But we're doing this, 1 over n power. That's what the nth root means, right? Nth root means 1 over n. So this, before we actually let n hit infinity, we have actually a 1 over n now. Because these exponents, this is 1 to the 1 over n, and this one becomes n over n. And so I'm just showing a little more detail. Now, 1 to the 1 over n, it doesn't matter what n is. 1 to that power, we can write it as a 1 right now. Before we let n go to infinity. Even if we let n go to infinity, it's still going to be 1 to the 0 power, which is 1 ultimately. So we're just going to write that as a 1. Now this equals 0, obviously, and that's less than 1, so we have absolute convergence. Okay, so let's squeeze another one in here. Here's problem B on that same page there. Now, without this test, we would have to, we could resort to the ratio test, and we probably would get somewhere with it. But this test is tailor-made for this problem. So we let r be equal to that limit, and we're going to have this 2 and n plus 1. And I don't need the bars in this case. It's the nth power, and I'm going to raise that to the 1 over n. See? Which is this limit, 2n over n plus 1. Now that limit is a 2. That's greater than 1. We have divergence. Okay, it's a divergent series. Okay.